Hello there, everyone, and welcome back to our virtual science classroom. This is your teacher Daryl Del Mundo, and today our new lesson is all about chemical bonding. Yes, and for today's agenda, we are going to talk about the definition of chemical bonding, the Lewy dot notation, the Lewy dot structure, and types of chemical bond. So, chemical bonding is very important in the field of chemistry because this is how molecules are being formed or compound that we all know came from atoms or element. So let's start with the discussion that we all know that atoms or elements can form a compound or molecule. So it can be the same atom or it can be different atoms that can be combined together that we call compound or molecule. And of course, we need to understand in this lesson as our objective number one is to differentiate types of chemical bond. Number two, determine the types of forces that exist between and among atoms and molecules. And our objective number three is to understand electronegativity and bond polarity. So these are the objectives that we are going to understand in this topic. So let's start with chemical bonding. Chemical bonding is a strong attractive force that join two or more atoms or element together. This is also the force that we all know that can make those two different or the same element close or combine to each other. Atoms bond to each other to become stable with their full valence electron. Remember the octet rule? Meaning to say, those elements are finding or looking for its partner to become stable, to become 8 valence electron or to have that 8 valence electron so that they will be able to have a stable characteristics. So in this process, the electron configuration of the bonded atoms is similar to the noble gases because noble gases has full valence electrons. So that's why this element and other element will combine together for them to be able to become stable like noble gases. So this is an example of chemical bond, another type of chemical bond or example of chemical bonding, and another structure of chemical bonding. So when you see those type of structures or models, those are examples of bonding that shows how two or the same element can be combined together. So now, there is what we call Lewy dot notation and structure. So it was proposed by Mr. Gilbert and Lewy. It is also called electron dot structures or electron dot diagrams, which we considered as diagram that shows the bonding between atoms of a molecule and the lone pairs of electrons that may exist in the molecule. So there are unpaired or the lone pairs, and there are also paired electrons. So later on, you will see that. And this type of model or structures shows each atom in the structure of the molecule using its chemical symbol. So you will see here different dots and also the chemical symbol of the element. Always remember that a Lewis structure is a very simplified representation of the valence shell electrons in a molecule. Okay, let's have this sodium chloride. So in sodium chloride, we have sodium here with one dot, meaning to say that one dot is equivalent to one valence electron. All right? So while on the other hand, chlorine has how many dots? 7. Okay, so we have here 7 valence electron. Remember, electrons are lazy. Instead that they're giving off the 7 valence electrons like chlorine, it will not be the one who will give out its electrons. All right? So what will happen is that chlorine will wait for the sodium to combine because chlorine is highly electronegativity or has high electronegativity than sodium. All right? So it means that the chlorine here is highly attractive. All right? That's why sodium will give off its one valence electron to chlorine to form an 8 valence electron until such time we have this kind of bonding. We have sodium plus chlorine, which is negative, and we have sodium here as the positive. So the name of this chemical compound is sodium chloride, and they are now stable 100% because of the 8 valence electrons, or it has 4 paired valence electrons. Is that clear? So that's what will you see, or those are the structures or the notation that you will see in Lewy dot. Okay? And of course, Lewy dot notation can understand this way. So we have here first column, second column, third, fourth, fifth, so on hanggang 8 column. Alright? So basically, you all have to do is to identify where is the group number of the elements. So when you find the group number of the elements, you will find also the valence electron. So for example, here we have hydrogen. So in hydrogen, it is located in the first column. So basically, all the elements that are in the first column has one valence electron. On the other hand, on the second column, it has all 2 valence electron. That's why you have 2 dots over there. Okay? And then boron, for the group 3A, it has 3 valence electrons. So you will see there 3 dots. And in group number 4A, we have carbon. That's why you can see 4 unpaired valence electrons here in their Lewy dot notation. Same as with silicon and so on. And then we have nitrogen, which is group number 5. That's why you can see here in nitrogen that it has 1, 2, 3, 4, 5. There is 1 paired valence electrons and 3 unpaired or lone pairs. Okay, it means that it doesn't have any pairs at all. And then we have oxygen, fluorine, and then we have here the noble gases that, as you observe, it has full 8 valence electrons. All right? So you will know the number of the dots for you to place it in a element symbol is based on its column, group, or family. All right? So the number of valence electrons that you put in the dot is the same as the group number or the family number. All right. And how are you going to draw the Lewy dot notation? So you will see this type of structure. Okay, but this one, it involves the bonding as well. So you will see here how carbon and chlorine combine together, and you will see the bonding by using those sticks. Okay, step number 1. Find the total number of valence electrons. Go to the group or the family. Step number 2. Find the number of electrons needed to make the atoms happy. This is the octet rule. So it means that you are going to find its perfect partner. If it is lack only 1, maybe any of the element in group number 1 will be its partner. If it's lack 2 valence electrons, of course, maybe one of the elements in group number 2 will be its partner. All right? And of course, in step number 3, determine the number of bonds in the molecule. In this case, we have carbon and 4 chlorine because carbon has 4 valence electrons. It means that carbon can bond into 4 other elements. In this case, we have chlorine. So the 4 unpaired electrons of chlorine or 4 paired valence electrons of chlorine combined or bonded to the 4 unpaired valence electrons of carbon. That's why we have here this type of structure. We have 1 carbon and 4 chlorine. All right? Of course, choose a central atom. So in this case, we have that central atom. And step number 5, draw a skeletal structure, which is this one. When you see this skeletal structure, this line, and this line, that is a single bond. If you see 2 lines, okay, that is double bonded. If you see 3 lines over there, it is triple bonded. Okay, so step number 6, place electrons around outside the atoms. 7, place remaining electrons around the central atom, C. Those are the paired valence electrons or remaining electrons that you are going to put outside the central atom. All right? And of course, you will write the line for you to represent or for you to show the bonding of the 2 elements. Okay? And next is that we are going to apply it. In this case, we have oxygen. Okay, oxygen is located in group number 6. That's why we have 1, 2, 3, 4, 5, 6. It has 2 paired valence electrons, 1 pair, 2 pairs, and then we have as well as 2 unpaired valence electrons or 2 lone pairs valence electrons of oxygen. So, for you to know the steps, okay, identify first the total number of valence electrons. Go to the group number or to its family. So oxygen is in group 6A, so it has 6 valence electrons. So when you're going to draw it, it must be look like this. All right, 2 paired and 2 unpaired. And then after that, if oxygen combined to its oxygen as well, or the same element as well, this will be it looks like, or this will be what it looks like. So we have double bonded because we have here unpaired electron and another unpaired electron, another unpaired electron, and another unpaired electron. Now, when they are going to bond, you will see there the double bonded line. So when you see only one, that's a single bond. If you see 2 lines like this one, this is a double bond. So this molecule or compound is known as oxygen gas or O2, meaning to say a combination of 2 oxygen. All right? So O2 is oxygen gas, and this is how you're going to show it in Lewis dot notation or Lewis dot structure. Okay? And of course, these are also other examples of Lewis dot notation that shows the bonding and also the paired and unpaired valence electrons. And these are all the skeletal structure of it, showing the single bond and the double bond. Okay? And in addition to that, there are also types of chemical bond. So the main types of chemical bonds are ionic bond, covalent bond, hydrogen bond, and metallic bond. A bond between 2 atoms depends upon the electronegativity difference between atoms. So remember that when you are in group 6, group 7, it is highly electronegativity or it has high electronegativity. On the other hand, when you go to the left side of the periodic table, meaning to say, you will go from 7 towards to number 1 or the first column, the electronegativity of the atom decreases. All right? So the greater the group number, the high the electronegativity. The lower the group number, the lower the electronegativity as well. So electronegativity class, again, it is the attraction of the atoms. All right, so when you are in group number 5, 6, and 7, you are highly attractive. All right, so let's start with the first one. We have the ionic bond, and this is the example of the ionic bond. Okay, So like the sodium chloride, because we have sodium and chlorine, when they react together, of course, sodium and chloride, or sodium chloride, which is known as the table salt, is the product. So ionic bond is a result of the attraction between ions. Remember, cation and anion. Ions unformed when an atom loses or gains an electron. These types of bonds are commonly formed between a metal and a non-metal. So remember, ionic came from ions, the attraction between ions. One metal and the other is non-metal. So in this case, we have sodium chloride. Sodium is the metal, chlorine is the non-metal. When it is non-metal, you will change its name. So from chlorine, it became chloride. So in ionic bond, we have that type of attraction. Okay, the attraction between ions. One metal and the other is non-metal. Okay, and then we have this example. We have atom 1 and then atom 2, which is metal and non-metal. So as you can see, when A gives off its electron, it becomes positive, and then B becomes negative. That's why they attracted to each other, and this atom A becomes the positive and B becomes negative because it gains electron. When they combined or bonded together, ionic molecule will produce. All right? And of course, number 2, we have covalent bond. Covalent bond, when an atom shares one or more pairs of electrons with another atom and forms a bond. This sharing of electrons happens because the atoms must satisfy the octet or the octet rule, the noble gas configuration, while bonding. Such type of bonding is common between two nonmetals. If ionic is one metal and nonmetal, covalent bond is composed or being combined using two nonmetals. Okay? So the covalent bond is the strongest and most common form of chemical bond in living organism. Again, it is the strongest and most common type of chemical bond in living organisms. Together with the ionic bond, they form the two most important chemical bonds. So in this case, we have covalent, which has unpaired valence electrons like this one. Okay, non-metal 1 and non-metal 2. So non-metal 2 can be a metalloid as well. So when they combine, they will share, or the valence electrons that are unpaired will fuse or bonded together, sharing the available valence electrons. And that's how covalent bond form. All right? And of course, covalent bonds can be single, double, and triple bonds as well. So like I've said a while ago, it can form different bonding. Okay, it can be single, double, or triple bonds. So we have here water for single bond. See the line over there. Then we have here the ethylene. It has double bond. And then acetylene, it has triple bond. Okay, so that's how covalent bond can be combined to other elements as well. And also, covalent bond can be classified by the number of shared electrons, the polarity of bonds, and the coordination of the atoms, which is based on the number of shared electron pairs. There are three types of covalent bonds. We have single covalent bond, double covalent bond, and triple covalent bond. In single covalent bond, this is when one pair of electrons or two electrons are shared between the atoms, which is known as a single covalent bond or merely a single bond. Like of the following, we have hydrogen gas, chlorine gas, bromine gas, iodine gas, and hydrochloric acid, NH3, CH4, and so on. And of course, we have the double covalent bond. It is when two pairs of electrons or four electrons are shared between the atoms. It is known as the double covalent bond. Like we have the example oxygen gas, carbon dioxide, sulfur dioxide, and C2H4. Alright? And next, we have triple covalent bond. In triple covalent bond, this is when 3 pairs of electrons or 6 electrons are shared between the atoms. It is known as the triple covalent or the triple bond. Examples are nitrogen gas, C2H2, and CN or cyanide. So we have single, double, triple covalent bond, which is based on the shared or the number of shared electron pairs. And to continue, covalent bond also based on the polarity of the bond and the coordination of the atoms. There can be 3 other types of covalent bond here based on the polarity. So we have polar and non-polar as well. So if we are going to base on the number of shared electron pairs, it can be single, double, or triple bond. But based on the polarity and coordination of the atoms, we have polar, non-polar, and coordinate bonds. So let us differentiate the 3. Number 1, polar covalent bond is likely to be polar when atoms sharing the electrons having a significant difference in their electronegativities. For example, between 1 to 2 as a result. So the bonded pairs is attracted toward the more electronegative atom, making that atom slightly negative and the other atom becomes slightly positive. So on this example, we have unpaired valence electrons, and as you can see, it has 1 unpaired valence electrons. This is 1 nonmetal and another nonmetal or metalloids. Remember, covalent, it is composed of 2 nonmetal elements. So when it attracts, this is now polar covalent bond. So B is attracted to this part because we know that this bond is okay, so in this example class, the sharing is unequal, although they shared the valence electrons. But as you can see here in our example, it is unequal, meaning to say the other one is benefited than the other one because the other one is highly or high in electron negativity, okay, than the other one. So an example of this is water. So when we talk about water or H2O, it is a polar covalent bond that shares valence electrons unequally. Okay, and next we have what we call non-polar covalent bond. This is when electronegativity difference between the atom is 0. Then electrons are equally shared between the atoms. In this case, covalent bond is non-polar. So the best examples of this are hydrogen gas, oxygen gas, meaning to say they are equally shared with their valence electrons. So we have 2 identical atoms, example, oxygen atom and another oxygen atom. That's why they are 2 identical. So when they combine together, the sharing is equally distributed. So non-polar covalent molecule exists in this case. All right, like the oxygen gas, hydrogen gas, nitrogen gas, because the valence electron is equally shared. Remember that. Non-polar, equally shared. Polar, unequally shared. Okay? Then we have the coordinate covalent bond or the dative covalent bond. So in this type of covalent bond, the shared repair or the shared pair of electrons comes from one of the atoms. So this kind of bond is typically observed in the bonding of metal ions to ligands. Okay, so we have atom 1, which is the electron donor, and atom 2, which is the electron acceptor. So if it has 2 paired valence electron and it will share to the other atom which lack two valence electron. So the sharing of valence electrons coming from A is evident in this case. So it's like a coordination helping hand in hand. So covalent molecule or the coordinate covalent bond exists in this type of bonding. Alright? So meaning to say the two paired electrons or valence electrons is going to share to the atom that lacks two valence electron to make it full. Okay, that's why it is called coordinate covalent bond. Alright. And number 3, we have what we call covalent bond a while ago. And today, we have hydrogen bond. From the word itself, hydrogen. So meaning to say, you will notice that the bonding exists in hydrogens. Alright? So hydrogen to oxygen, this is what we call covalent bond. But when you see hydrogen to hydrogen, that is what we call the hydrogen bond. Okay, so in this case, this is the hydrogen bond, and in this case, this is the covalent bond. So it is the interaction involving a hydrogen atom located between a pair of other atoms having a high affinity for electrons, such as a bond that is weaker than the ionic bond or covalent bond, but stronger than van der Waals forces. Okay, so hydrogen bond, it will be noticeable when you see a stagnant water. So when you see that the water is very stagnant and it has no movement at all, you can place anything on top of it, right? It's like it has a covering on the top of the water. And it is because of the hydrogen bond. Alright? That is, we can consider a weak bond. Alright, so that's why you can see some insects that can walk on the top of water. There are also other organisms that can be found on the top of water, something like that, that almost they can walk on water because of the hydrogen bond that form in that area. Alright, and also in making ice, you will see also hydrogen bonds there because you use water. So hydrogen bond is evident in that case. And number 4, we have metallic bond. So from the word itself, metallic bond, it is a type of chemical bond formed between positively charged atoms in which the free electrons, here are the free electrons. There you go. You see there the small blue that has wiggling movements. Those are the free electrons that are shared among the lattice of cations. Lattice is the crystalline-like structure, okay, of the cations. In contrast, covalent and ionic bonds form between two discrete atoms, while metallic bonding is the main type of chemical bond that forms between, of course, two or more metal atoms. There you go. This is an example of a metallic bond. Electrostatic attraction between the electrons and metal ions. That's how one bond is different from another type of bond. And of course, this bonding is very important when we are talking about molecules or forming a compound, because bonding of elements has an important role when it comes to the naming of these molecules or compounds. So let us be excited on how to name these molecules on our next topic. That's all for now. I hope you learned something today. Have a nice day and God bless you all.